Following the absolutely seminal paper that Peter Armitage and Richard Dole wrote in 1954, outlining the multi-stage model of cancer, Richard, who joined Richard Dole in 1967, spent a lot of the next 10 years looking at it quite hard to see what could actually be inferred from it. It was a wonderful airy-fairy model, but did it actually give you any solid information about carcinogenesis, about what stem cells do, about what carcinogens do, how to prevent cancer, so on and so forth? And he wrote this paper, and as Val mentioned, I mean, there's a collection of scientists who feel very strongly, as in fact I do, that this really ought to be better known. Now, luckily, it was published in an obscure book, but it was republished in the International Journal of Epidemiology in 2016. And I really do recommend that people read it. I mean, it's a classic piece of scientific writing, and it's, I think, virtually as relevant now as it is then. It's like reading The Origin of the Species. I mean, you know, we know all sorts of things that Darwin didn't know, but he was dead right about everything. And this falls into the same sort of category. I mean, Popper said that the origin of the species wasn't actually, the evolution wasn't a scientific theory because it couldn't be wrong. And I mean, maybe this falls into that category as well, but you can judge for yourselves. Now, I mean, there's a great deal to it, and I can't begin to go through it all. I just wanted to pick out a couple of things. The fundamental idea, which Richard Dole had written on, I mean, particularly a classic paper that he wrote in 1970 or 71, saying that the rate of damage is independent of age. And then the core idea that the progression from a normal cell to the pre-cancer, the stage before cancer, involves multiple steps, some of which are accelerated by carcinogens in some cases. And the last one is particularly relevant to what I want to talk about, which is that the pre-cancer, the stage before the cancer, these mysterious cells which just require one further step to become a cancer cell, and we don't actually know what that step is, but we're pretty sure it's not driven by mutagens, because when you stop smoking, your lung cancer rate doesn't drop. It goes up as the fourth power of how long you've been smoking for. And I mean, Richard's analysis of the doctor's smoking cohort was the best data set there ever has been, or ever will be probably, on very precise measurement on exactly who smoked how much and when they stopped. But when you stop smoking, your lung cancer rate essentially freezes. It might go up and down a bit, but I mean, it essentially freezes. And what that suggests is that this pre-cancerous stage, which has been produced by smoking through a multi-stage process, those cells just sit there for the rest of your life, turning into cancer at a constant rate. And what that is, I mean, what on earth is that final step? I mean, there are some quite interesting questions about how cancer works, which I don't think that the people who work on carcinogenesis are all thinking about as much as they should. And the only people who are really thinking about it, I think, are the stem cell biologists. It's not affected by carcinogens. Therefore, this is a key point, the cancer incidence rate is proportional to the prevalence of pre-cancer in the population, or the number of pre-cancer cells you've got in you. So if you're a smoker, you've got a certain number of pre-cancer cells, and that determines your risk of getting lung cancer is just proportional to that number of the cells. Richard did a very nice experiment in the early 1970s where they painted mice with benzpyrin starting at age 10, 25, 40, and 55 weeks. And on the left-hand side, you can see that the cancer rate goes up, you know, starts going up first in the people who painted the mice, the mice who were painted earliest, and so on and so forth. But when you plot the data by time since beginning exposure, they're all exactly the same. So it's a very elegant, direct demonstration of the fact that aging itself has nothing to do with it. It's just how long carcinogenesis has been going on for. Now, these ideas, and the ideas in Richard's 1977 paper, or 76, whatever it was, which you must read. Okay, I mean, ask me afterwards for the reference if you didn't write it down, International Journal of Epidemiology, 2016. Those ideas had a big influence on a lot of people who worked with Richard Dole. I mean, Malcolm Pike wrote a thing in Nature in 1983 about, you know, sort of the extension of it to describe the effect of hormonal changes and explain the age distribution of breast cancer and so on and so forth. I mean, a few years later, I got hold of the mesothelioma data in the American Installation Work. It was a huge set, 175 mesotheliomas. And of course, the first thing I did with them was plot this graph, and it's exactly the same. I mean, they're people who first exposed to asbestos at age 20, 30, 40. The people exposed at age 40 they die of old age before they have time to get mesothelioma. But if you plot them by time since first asbestos exposure, the curves are absolutely identical. And so it's informed the way people have looked at both, I mean, practical questions like this and theoretical questions about how cancer works ever since. Now, we come to the Maiden's Prayer. I mean, this is, Richard lost interest in all this in about 1977. I remember him saying to me that he'd been doing cancer research for 10 years and he didn't think he'd saved a single life. So he's going to change direction. And this meeting has essentially been entirely devoted to what he did after he changed direction in 1977. So I'm talking about what he did before 1977. And it really was seminal. But it's still relevant. And so now I want to talk about what I've been doing for the last 2 or 3 months. The problem with cervical cancer is that it's all caused by HPV, the human papillomavirus, which is sexually transmitted, hence the Maiden's Prayer. Most women have been infected. I mean, well over 50% of women have been infected, and most of them were infected before the age of 25. And I mean, an infection is a lot rarer after 1945, after age 45 or 50, for obvious reasons. And so what we know about it is that the screening age was raised from 20 to 25 in 2004 because screening at age 20 was thought to be ineffective. And that has, in fact, and the latest data, just the data from 2016, you got a whole sort of 5 years, and the cancer rate has increased quite substantially in women aged 25 to 29 who were born after 2004 as a result of it. And we need to understand why that was. I mean, it's no longer very relevant because of HPV vaccination. The vaccinated cohort are just beginning screening, so the risks are going to be much lower. But I mean, most of the world hasn't been vaccinated. I mean, all the women who were born before 1991 weren't vaccinated. And on top of everything else, we're now changing over from cytology to HPV testing. It's actually replacing cytology at the moment, and it'll be complete by the end of next year. So we're replacing cytology with screening. We don't understand how cytology works, and we've got no idea how to do HPV screening, what age you should do it from, how often you should do it, and so on. So it's quite an important question. So, the multi-stage knight to the maiden's rescue. This is the age distribution of cervical cancer in unscreened populations. These are actually death rates in Britain in people born in about 1920. Screening was introduced very suddenly in 1988 in Britain. That's a key fact in what I'm going to say. And so from 1988 onwards, all women in Britain over the age of 20 were invited every 3 or 5 years for screening, and most of them attended. So we went basically from no screening to universal screening very abruptly. But this is what happens with no screening. The cancer rate is zero below age 20. It's tiny at 20 to 24. It's creeping up at 25 to 29. And then it goes up very, very steeply to about 40 to 44. But then it flattens off. And from age 50 onwards, right up to age 80, in fact, it's as flat as a pancake. It just doesn't change at all. Now, of course, what the multi-stage model says is that the fundamental assumption is that cervical cancer incidence is proportional to the prevalence of cervical pre-cancer in the population. So this is you know, how many people have got cervical pre-cancer in the population. And not surprisingly, it goes up incredibly steeply with HPV infection during the period when HPV infection is common, up to the age of 30 or 35. As HPV infection becomes rarer, it flattens out, and when there's no more HPV infection, it stays where it is. So screening is aiming to detect pre-cancer and treat it. That's what cervical screening does. Now, we want a mathematical model to describe this. That's what statisticians like. So I must mention the effect of screening. This is what happened after 1988. These are people born, these are women born in about 1933, who were 55 in 1988 when screening started. So their cervical cancer rate goes up until they're 55, but then it drops. Remember that they stayed constant in unscreened populations, which incidentally is seen in every developing country in the world. If you look at within birth cohorts, in unscreened populations, you get the same pattern of going up to age 45 and then just flattening off. These people are born in 1933. These people are born in 1943. So they're screened from age 45, and their rate goes up to age 45 and then drops when they start screening. And these people are born in 1953, you get the same thing. So the effect of screening is to detect pre-cancer and treat it, and therefore reduce the cancer rate. Lovely. But we want to quantify that. So what's the best model? Well, the simplest possible model that's consistent with what we know is that every new HPV infection has a constant probability, averaged across HPV types. I mean, some are worse than others, but I mean, on average, a new HPV infection has a fixed probability of causing a pre-cancer, SIN3 or carcinoma in situ, whatever you want to call it. We know the age distribution of HPV infection because we've done big studies, and we get people who haven't got HPV and ask them if they've got HPV. We did ask them, actually, we take a sample. 3 years later, and see how many of them got it. So we know the age distribution of new HPV infection. So we know the age distribution of pre-cancer. Now, pre-cancer progresses to cervical cancer at a constant rate, the fundamental multi-stage assumption. And the other thing you have to put in the model is the lag. There's a 7 or 8 year lag from HPV infection to the first diagnosis of the cancer it causes. And we know it's more than 5 years. I mean, plenty of people get HPV when they're 14 or 15, and nobody ever gets cervical cancer before they're 20. One of the 2,600 cases in 2016 was aged under 20. But it's quite common by the age of 25. So we know it's somewhere between 5 and 10 years, so say 7.5 years, from HPV infection to the manifestation of cancer. And we then got to put screening in. Well, I mean, it reduces it by a certain proportion every time you're screened. And it turns out, surprisingly, that the best estimate is 40%. But anyway, so there's only two parameters in the model. There's the 7.5 year lag from getting infected to any effect on cancer, and 40% of SIN3s are detected every time you screen. And so the inferences we can draw is that cervical pre-cancer is cytologically normal more than half the time. You only pick up 40% of them every time you screen, which is very surprising and offensive to most people who actually spend their days looking through colposcopes, because they define SIN3 as a severe dysplasia that penetrates the epithelium. So obviously it's visible. But what this very strongly suggests is that that's not true, that it's there in the basal layer, it's causing cancer, but it's not manifest on a smear, and it's not manifest to a colposcopist. So now we understand why raising the screening age from 20 to 25 increased the cancer rate. And most important of all in the modern context is we now know how to do HPV screening, or at least we've got a framework within which to decide how to do it. We know what's going on, we know what the aim of screening is, and we know what to measure to decide how to do the screening. And so the answer to the Maiden's Prayer, in a sense, all that doesn't much matter in Britain. I mean, the number of cervical cancer deaths has dropped now below 1,000 a year, and it's still dropping. And with the advent of HPV screening, however well or badly it does, it'll do even better. But it's a major problem in the developing world. I mean, it's the second commonest cancer in women after breast cancer in the developing world. And there's 500,000 cases a year and 250,000. And I can't compete with Richard, but I mean, 250,000 deaths a year is not bad. And 80% of them are after age 45. And what this model strongly suggests, and is pretty obvious anyway, is that virtually all of those are caused by pre-cancer, which is there at age 45. So if you give one test at age 45, a sensitive HPV test, you'll detect the whole lot. Now the question is what you then do. I mean, in Britain, we recall women every 5 years until something happened or nothing happened, and a whole lot of them would get cancer while we were doing it. But in fact, the effect of cervical, the only serious contraindication to cervical ablation in a postmenopausal woman is the risk of premature delivery, which is 0. So if you test all postmenopausal women with a sensitive HPV test and treat the whole lot, you can eradicate most of those 80% of cervical cancers, which is 200,000 deaths a year in the world. As I say, I can't compete with Richard, but it's not bad going. But it's all thanks to his model, which he wrote in 1976. And as I say, he said he was giving it up. He said he'd spent 10 years doing that, not saved a life, so he was going to do something else. But I mean, there's still something in what the old dog said 41 years ago.